Hello friends, you are welcome once again to our chemistry class. In this our chemistry class, last time we discussed about WAEC practical and I believe it helped you to do well during that exercise. Today we are going to be discussing something on Neco chemistry practical 2025. I know that it will help you a lot if you follow to the end. So now, without wasting time, let's see how question 1 will be. As you all know that question 1 is always about titration and calculation in chemistry, while question 2 is always about identification of ions. Then question 3 is general question. It can come from anywhere in chemistry. So in this particular video today, I'm going to treat question 1, which is about chemistry titration, which is question 1. Now let's see the question. A is a solution containing 0.095 mole per dm cube of trioxonitrate 5 acid. B is a solution containing 8.0 gram per dm cube of a mixture of Na2CO3 and NaNO3. A. Put A into a burette and titrate it against 20.0 cm3 or 25.0 cm3 portions of B using methyl orange as indicator. Record the volume of your pipette, tabulate your burette readings, and calculate the average volume of A used. Equation for the reaction is given there. You can see. Now, B. From your result and the information provided above, calculate the I. Concentration of Na2CO3 in mole per dm cube in B. II. Mass of Na2CO3 in gram per dm cube in B. III. Percentage by mass of Na2CO3 in the mixture. IV. Mass of NaNO3 in the mixture. They have given you atomic masses of each element there. Now, when you have a question like this, what you need to do, if you check B is a mixture of two substances, two salts. It is not the two salts that will react. It's just one that will react. So the equation is telling you the one that is reacting and the product formed. Okay, so let's see the solution. They told you to record what? The volume of pipette that you're using. So solution, above the table, you just start by writing the volume of pipette equal to, like in this case, I was using 25.0 cm cube. I do not know the one that your school is using. If your school is using 25.0 cm cube, you record that. If it is 20, you record that. And then also very important for you to tell them, despite the fact that they have told you the methyl orange you should be using, just tell them indicator equal to, you mention methyl orange. Now they said you should do the titration. Maybe your teacher might have given you the directives on what to do on the table. but I need to add few things to that. So this table you are seeing here is the one I did in my lab. There's no point for me to come here and start spending much time doing the titration. You know how to titrate. If you don't know how to titrate, search for titration in this my channel. I've done that before, so search for it and watch. So, but draw the table the way I'm doing here. Burette reading, raw first item, second and third, final burette readings. Very important. This CM cube you are seeing me putting by their sides, initial burette readings and volume of A used is very important. Put them, because by the time you fail to put them and you finish the titration table and then calculate everything, we won't know. We will assume not to know. We will pretend not to know the unit you are using. So it is very important, but by the time you put them by the side, it makes your work neat. So you put them the way I'm doing it, and then do the titration. Record them the way I'm doing. If you see the table is neat, I do not write and rewrite and rewrite. That will take your mark. I taught you this. I took time and then explain all of these, what your examiner needs on your table for them not to mark you bad. If you have not watched that video, go just few videos behind, you will see it. I did that before WAEC. So follow it and then know what you are being, or what you are to do in this particular exam. Okay, so now the table is given. You have seen the values. You have subtracted your initials from final. If you fail to do that, your examiner will do that for you and will deduct your mark. Then they told you to calculate average volume of A used. So you can see I'm using two values, two title values. Some persons may prefer to use three, but if you are using three, be sure the first and the last, or the highest value, the biggest value and the smallest value, when you subtract them, you will not have anything more than 0.20. If you have, you are not right. So here my difference is 0.1, 24.90 plus 24 or minus 24.8 is 0.1. So the values are concordant. So you use such and do your average. So if you check the table again, all my values are in two significant or two decimal places. Very important. Two decimal places. Very important. Okay, now let's move down. BI, they said you should calculate concentration of Na2CO3 in mole per dm cube in the solution. Concentration. So what they gave you there in the question was not concentration. Look at there. B is a solution containing 8.0 gram per dm cube of the mixture of this and this. So these two values or two substances are sharing that 8.0 gram. So that's the reason you have to start it using CAVA over CBVB. Since they have given you the concentration of A in mole per dm cube. Assuming they gave you in cm cube, maybe 500 cm cube or 250 cm cube, you know what to do. That's just convert that by saying so value in so cm cube, so value equal to so cm cube. 1000 will be in x. You cross multiply, you know all of that, and then get your value. But this one goes straight and then bring this formula. CAVA all over CBVB equal to NA all over NB. Now, substitute the values. Ca is the concentration of acid that they have given you here. They have given you 0.095. So, you substitute it there. Volume C of VA is your titer value. Is your titer value here. Average volume of acid used. Now, CB is what you are looking for. Then the VB is the volume of pipette. Now, NA over NB is the mole ratio of acid to base. You go to equation. You can see balanced equation of that acid, of that a reaction. You have 2:1. 2:1. That's why we are putting, that's acid and base respectively. You put Na, you put 2. Then for NB, you put 1. In that place, you are done. Once you are able to substitute correctly like that, then move to the next step, which is making what? CB subject formula by cross multiplication. So if you cross multiply, I know some of you may be having problem here. Since you are looking for CB, cross multiply. That's multiply this by this by this. That means CB equal to this times this times this all over this times this. That's what you have to do. Okay, you have seen it there. And then use your calculator, get the answer. The formula will take you to, if you are using that formula, the unit of the answer will always be in mole per dm cube. So you are done with that question. Go to II. It said mass of Na2CO3 in gram per dm cube. In gram per dm cube. So the formula is molar mass times molar concentration. You have seen it there. Molar mass times molar concentration. So the molar mass, you can use those atomic masses and then do the molar mass. So here, let's start with the molar mass. If you see the molar mass here, Na, they told you 23 times 2. C is 12. O is 16 times how many? 3. So add all. That means this times this is 46 plus 12 plus this times this is 48. Add all, you have what? 106 gram per mole. That's molar mass. But remember, you were saying here, molar, that in gram, mass in gram per dm cube is equal to molar concentration times molar mass. So where is molar concentration? Your molar concentration is this. Where's your molar mass? Your molar mass is this. So substitute them in this. Mass of this in gram per dm cube equal to this times this, which is this. But always keep it in 3 significant figure. So I approximated it. That gives me this. Okay, so that's the answer to that question. Move again to the next question. They said percentage by mass of Na2CO3 in the mixture. Percentage by mass in the mixture. So that of NO3, which is what you just calculated, this value, all over the total value of the two mixture in the question. If you remember, it was 8.0. So times 100. Substitute that, you get 62.5%. Then the next question says mass of NaNO3 in the mixture. So the formula for that is equal to mass of the mixture minus mass of Na2CO3 because they are together. So that gives you 8 minus 5, which is equal to 3 gram per mole. So you have successfully done everything. If they ask you again mass of the other substance, okay, mass of NaNO3, they ask you the mass of the percentage by mass of NaNO3. So you use this value now, all over total, which is 8 times 100. You get the percentage of this in that solution. So you are done with that calculation, and you should be expecting something better. So I believe with the few things that I have shown you today, you will perform excellently well in your Neco Practical 2025. So keep on watching and keep on following the channel for more. I will soon drop the solution of question 2. So keep following and let's see the outcome when your result comes out. Thank you.